This project aims to predict yield and harvest timing in order to improve workforce planning, pricing negotiations, and the planning of operations around weather events. And the particular focus of the project, in partnership with Costa Berries and Treasury Wine Estates, is around the berry industry and wine grape industries respectively. So Dan, great to see you. Thanks for joining us. And over to you, mate.
Thank you. I'll just share my screen. Okay. Well, good afternoon all, and many thanks to those involved in inviting us to present on our project. The topic we're presenting today is a 2-year research project that finished up in July this year. Our focus, as Dave was talking about, was tackling the question of how to predict when crops, when to pick crops and how much crop will be produced. So this is a major area of agricultural research and has to date proven quite challenging. There are 3 reasons for this. The first is that crop production is highly crop dependent and a wide variety of features can dictate crop success or failure. These can include weather, location, soil type, planting conditions, plant biology, and management decisions. Secondly, collection of sufficient data on these important features is often haphazard or else not digitized. So this reduces the ability of us to use historical data to predict future crop production. But lastly, and probably most importantly, is that analytic methods and computational capacity for combining these different types of data have been relatively inadequate until recently. So these 3 hurdles are important to overcome, because if you know when to pick, you can assign resources and plan logistics ahead of time, and that makes these processes more cost efficient. If you know how much to harvest to expect, you can make market and sales decisions up the supply chain from the field to the consumer. So this is the challenge that we set out to tackle in this short 2-year project. So through this food agility project, we're able to combine the required skill sets among different partners to make significant inroads on our objectives. At UTS, our research team specialises in microclimate prediction, remote sensing, and plant biology. And our past research has highlighted just how important microclimate is for survival and plant growth. Microclimate differs from weather readings that you get on your phone because it represents the conditions experienced at the plant scale, the very local scale. And it's common for plants to experience temperatures of up to 20 degrees different from what we might call macroclimate conditions, the conditions that are measured by weather stations. So over the past decade, we've been exploring how fine-scale patterns in microclimate can drive productivity in plant species. And while we've been exploring this primarily for wild plants, it was only natural that our work was utilised to tackle crop productivity and estimation. We therefore combined our research here at UTS with the state-of-the-art data and machine learning expertise at the Yield. And they've also provided access to data from 2 of their major clients. And of course, we benefited from close collaboration and project management led by the Food Agility CRC. So our targets were Treasury Wine Estates and Costa, and the Yield were engaged in commercial relationships with these 2 primary producers, both of whom required data-driven methods for estimating crop yield and crop timing. So for those who don't know, Treasury Wine Estates is a global wine producing company with vineyards across Australia, and Costa is one of Australia's largest berry and food producers with large blueberry and raspberry operations across the east coast of Australia. So the really interesting thing about this is that we had the same objective, but we had different requirements. So we split the project across these 2 crop types, wine grapes and then blueberries and raspberries primarily. And each of these crops has distinct biology, growth stages, growing systems, management, data, markets, and end user requirements. So these differences resulted in 2 parallel but unique solutions to what appeared at the outset to be the same question. So I'm going to give a little bit of background about these two different crops and show you where they sort of differ. So in terms of their biology, grapes are annual, whereas berries can produce continuously. So if you therefore with berries get a multiple harvest per year, whereas it's only single harvest for grapes. Probably one of the primary differences here to note is that with grapes, the fruit grows and ripens on the plant together, whereas on berries, the fruit growth is non-synchronous. This then affects the way that the crops are harvested all at once for wine grapes, as they ripen for berries. In terms of their growing system, again, it's very different. Wine grapes are in the field, whereas blueberries and raspberries are often in pots, sometimes also in glass houses. In terms of the climate that they're experiencing, wine grapes, typically there's no manipulation around the kind of heat or the microclimate they're experiencing. And yet for berries, it's intense in the sense that the pots are left chilled and then they're brought out of chill and put into glass houses so that the heat that they experience and the microclimate manipulation is vital to indicating how much product they will produce. So for wine grapes, macroclimate can be more important, but for berries, microclimate can be more important. Again, they differ in terms of the way in which they're managed. So for wine grapes, you might have multiple growers and different management styles across various vineyards across the wine producing regions. And they might have distinct management processes that they might implement on a sort of annual basis. So certain times of the year, they might do certain things. Whereas that's vastly different for berries, where there's fewer sites. They have very strong on day-to-day on-site practices around the management of those particular plants. With wine grapes, harvest timing decisions might be around the logistics of labour and avoiding deleterious or adverse events in terms of the weather. So if you know that there's a storm coming, you might want to try and harvest quickly. Whereas with berries, there's kind of an ongoing process. A big difference then is the kind of data that's available. So for wines, we had data available for over 1,500 blocks across multiple vineyards, lots of different varieties of grapes. There's only one pick per year, so that meant that for every annual year, we only had one set of yield data to work with, but we had multiple years. For berries, on the other hand, we had very few sites, but we had lots and lots of harvest data because we had continual crop data coming in, continual yield. In terms of the markets then, what happens to those? Grapes can obviously be turned into secondary products like wine, and they might get some of that in-house, but they might also buy grapes from other producers. In terms of the quality that they're after, there might be lots of different grades. So they're not always optimizing for maximum yield. They might be interested in having a range of grades of production. Whereas with berries, high yield is vastly important. And when those yields come into play, so the timing of when those crops are desirable is very, very important. So we had to make sure that we covered off on all of these different types of data in our management style. Then in terms of the end user, there are different requirements. So for example, if you're a wine producer, you're really interested in that sort of bi-yearly production in November and February to know how much you're going to produce. And that then enables you to schedule what kind of logistics you need in terms of labor and so forth, and what markets you might sell into. From a berry point of view, it's really a week by week. So the actual timing is less important than telling users which blocks are the ones that they need to focus on in terms of picking. Okay, so taking all that wealth of information that you're now fully up to speed on in terms of the different kinds of crops, what we tried to do is try to build an analytics approach that covered off on all of those different suites and sets of data but was still flexible and malleable to the different challenges that each crop produced. Hence, our approach here was to invest in some data-driven machine learning models targeting the specific needs of each crop while working closely with growers to understand the challenges and their requirements. And we did this in partnership with Yield, combining our expertise to develop an analytics framework that could predict crop timing and yield for both grapes and berries. So the goal, our overall goal, was to be able to identify and deliver on research objectives. So those areas requiring new knowledge and thinking, because we're researchers, at the same time as being able to produce production objectives. So that might be coding platforms that enabled the Yield to make robust prediction forecasts for their clients. So combining these two goals simultaneously was both immensely rewarding, but also incredibly challenging. So for example, in terms of the different kind of data analytics approaches that we utilized in this case, for the wine grapes, we've had to focus on gridded weather and remote sensing. We used a lot of variables like rainfall, growing degree days, extreme temperatures, and so forth. And our model predictions were aimed so that we could make them 9 to 1 month out from harvest. In contrast, for berries, our focus was very much on the microclimate side of things, differences between the different berry types and locations. And our model predictions were aimed at making predictions 7 to 0 weeks out from harvest. So the analytics, So the analytics required to build and test the harvest and timing yields for wine grapes pose specific challenges. We were using historical data from vineyards that were from geographically and climate diverse regions, meaning that we had to accommodate for a wide range of potential variation in both business as usual weather and extremes. So additionally, we had to combine sparse historical data on past yields and crop management interventions with vast amounts of data and data sources available on historical weather, including hourly weather data and remote sensing satellite data. So this required a sophisticated data ingestion and feature engineering to make use of the best of these poor and rich data sets that were available. In addition, we had to, so this is an example of the kinds of various different types of the climate variables that we had to account for, and the way in which they were sort of varied across space. In terms of the berries, they presented a very different challenge. The primary problem was to be able to develop predictive models of when berries would be ready to harvest and how much would be produced. We firstly built models that enable us to predict microclimate conditions from macroclimate, because only historical macroclimate was generally available. We then used these microclimate conditions to predict the weeks before harvest could start, and then the weeks left before the end of harvest. This also enabled us to then model the cumulative yield across the harvest. The key novel component of this work was the development of new data-driven methods for estimating heat energy required before the berries open. So this first part of this model, so you got the timeline down the bottom. The green line represents weeks to harvest, and as the weeks to harvest declines, that declines because the cumulative heat energy that the berries are experiencing increases to a point where they're actually ripe. So we were able to forecast that. And then the second part of the project was what this model structure was predicting the weeks to when the harvest would end. So that obviously is when the cumulative yield becomes 100%. So in terms of results, staying very broad here for commercial reasons, for wine grapes, our harvesting timing models proved to be highly accurate using historical data. However, when these models were integrated into the yield's larger production environment, accuracy settled to around 12 days, which was not that different from TWE's in-house predictions. Targets for yield accuracy were also set in consultation with TWE and the yield at key times of bud burst, that's November, and also around veraison, which is February. Both of these targets were met, which was extremely pleasing for all concerned. In terms of berries, our research developed new methods for heat use, for modelling yield and timing of berries. And this was instrumental in building 9 models, production models, operating every day within a yield. So that's across 3 sites and 4 types of berries. The values noted here represent the current state of prediction accuracy, and the research is continuing to be integrated into production to find improvements where possible. So in terms of the Eureka, I guess the key successes and impact of this project are that the yield was able to secure off the back of what we built with them, ongoing contracts with their clients. We were able to assist in transforming the data analytics platform and focus within the yield, contributing to their ongoing development and success. We also greatly improved the skills of 3 postdoctoral fellows that we were able to hire, and each of those have gone on to secure funding and positions in agriculture, conservation, and forensics. And as part of this, several follow-on projects between UTS and the yield have materialised. Not to forget the gnarly though. So these successes didn't come without significant hard work and overcoming some challenging issues. 2 of our postdocs were caught overseas in early 2020 and never made it back to Australia, including one who was visiting a remote island in the Philippines, and she's been stuck on it, and she's still stuck on it. So we had to invent novel ways to get a laptop sent to her. We also had to develop and implement data security measures that allowed for efficient computation and protection against data loss. And this was not a small measure, and Food Agility in the yield really assisted in thinking through how we can protect the data that we're using, particularly when we had staff members who were both in Australia and overseas participating in developing code on a daily basis. One of the really key challenges was aligning research and industry goals under the FLIP research model, primarily around the ability to be agile. And this was something I think all sides struggled with, but it was really pleasing to see us get over that. And it certainly was a steep learning curve for all partners. So in conclusion, overall, we strongly feel that the project was a success, with the models being developed, tested, and now deployed in a customer setting via the yield's ongoing business. We were able to build models that can predict harvest timing and yield with good accuracy for a range of crops and conditions. And while the initial questions and goals were the same for each crop, differences between the 2 target crops and end user requirements resulted in very different approaches from the initial design, although all the way through to how predictions were provided and aggregated to the client. And we hope that the legacy of this short project will continue to translate in growth of agtech and data analytics to maximise production in sustainable and climate resilient ways. So I might have finished early, so hopefully that's time for lots of questions.
Thank you, Dan. To you and the project team. I have a couple of questions come in. I also want to start by a comment. This project is, again, one of the projects that have been with us since the early stages. And, you know, there was a lot of talk about agile and agility and about Food Agility's ability to be agile. But if it was this project where we really learned what it took to do the walk. And so the experiences Dan was very quick to mention, they really consumed your team, Dan's team, and the yields team and us, was how we could actually activate that in reality. So it's not a small point, it is a massive learning experience. And so I guess, Dan, I owe you and the team thanks for teaching us how to walk the walk after doing a lot of talking of the talk. So that's something I just wanted to publicly say. Dan, now, forgive me, you can fob this question off. I read between the lines somewhere. You made a comment along the lines of the model performance was really good. You're really happy with it. But then it almost implied that, you know, when you did the translation piece into the delivery system, the industry system side, it was almost like there was a penalty to accuracy or functionality. Was that the case, or just more after some general comments? Don't have to give us the details.
Look, so basically what we would do in a research environment, you're given the data that you work with. we weren't given access to all of the data that is generally available. But what we did was we built, the purpose of research, and where research, sort of the injection of research into industry partnerships, is where there's something new that needs to be created, right? And so our team was really successful in thinking through, well, where are the knowledge gaps and how we can sort of build models to not only understand those, but then explore those relationships. So you might end up with a model that predicts yield based on tackling a particular element of all the different kind of complex data suites that I was mentioning. The issue then is that might work brilliantly and you might get really, really super accuracy. But when you bring it over into a commercial setting where you've got a larger production environment that might have certain constraints, that might also already have other external management factors involved, then they might either, there's an interaction there, right? There's going to be some kind of relationship that sort of builds that may or may not benefit this sort of simple approach that you might have taken. So, I mean, this is probably a question that I think that some of the yield staff that were directly related in trying to engage in that translation process. So we weren't responsible for the translation, but we assisted the yield in understanding what we'd done and providing them with our code so that it would speed up the translation process. But I guess that it's just the vagaries of the larger picture, I guess. There might, just different sources of data. I don't think, and I guess the point I was trying to make is that I don't think, from a research point of view, I consider that a major win, that we were able to tackle something that hadn't been tackled before. We used purely data-driven models, and we got great outcomes with the data that was made available. And data availability was definitely a challenge. The issue is that that doesn't always necessarily mean that in an industry setting you're going to get exactly the same result. So I think that the yield would still consider, and TWE for that matter, we can still consider it a win that we were able to match their expert timing models purely from a data-driven point of view. So I still think it's a win. It's just that it was slightly different than what we'd hoped.
Yeah, and just along the vein of these peripheral, not peripheral learnings, but these other important co-learnings. So, I mean, your team was very deeply embedded with the industry side. So you're working hand in glove with Treasury Wine Estate, Costa Berry's teams, but also with the yield. As a researcher and as a research manager of a project, how did you find the experience of having key researchers like postdocs actually embedded with industry? I mean, Alistair Clark's embedded with Sunrise. Didn't have a chance to ask Alistair this, but I'd love your perspectives on what it was like what they felt like being embedded deeply within the organisations.
Well, look, it's a wonderful opportunity that these kinds of postdocs get. There's no doubt about that. The challenges that industry present and the way in which they operate is often very different to the way in which research operates, and that can create a tension. But I think the key there is maturity, and this is something that sort of came out amongst the many discussions that we've had over the last couple of years, right? So as the relationship and level of understanding on both sides progressed, that the space and the tensions between how they should operate seem to become to ease, at least. So it's certainly what, it would be remiss of me to say that it was all hunky-dory and that it all went really, really smooth sailing. It was definitely an important challenge to overcome, and only by experiencing that challenge were we able to really understand what objectives, what goals would the yield and their clients really benefit from. So that immersion gave us that experience. Sometimes though, that idea of, well, in order to do research, it's always a little bit pie in the sky. There's always going to be an element of let's try something. And sometimes in a commercial setting that understanding of how to provide the flexibility to allow that to happen can be challenging, particularly when you've got deadlines. So I think that one of the key things that we realized is that it's really important to enable the researchers to do research that benefits the industry, but not necessarily rely on them to deliver on industry-related targets with their clients. And I think that the yield and us learned a lot through that process.
Thank you, Dan. These are really valuable insights. And as I said earlier, we learned to walk through this project. And I hope these insights are valuable to everyone else in our group, in our family listening at the moment. Dan, I'm going to go back to your eureka moments, because I'm going to suggest that they are great wins for the project. But as a researcher, did you have a personal eureka moment, something when the penny dropped with you in relation to your interactions with the industry side about what you were trying to do or what were you trying to build?
Well, that's a good point, Dave. I mean, look, I guess where I sat, I was mostly involved in the management of the project, providing the intellectual insight or the scientific nous, whereas the three postdocs were the ones who were the ones actually doing the coding. I didn't do any of the coding, I have to admit. I did review it, but they're the clever ones, not me, really. The issue, I guess, in terms of, so the eureka moments were for me around understanding the relationships and where best flip research can happen. So in apropos of the last question, I think though, and you know, I could try to speak for some of the researchers, I think that the knowledge they gained of the way science and particularly the kind of analytics that we were doing can be used to drive incremental progress in an industry framework, I think was a bit of a eureka, in a sense that it's not always about trying to do something until it's 100% perfect. That in an industry setting, science and research can be iterative, but you need wins all the way through. They just don't need to be perfect all the way through. And I think that as a whole, our group took that message away.
Thanks, Dan. And I have an anonymous one, but if you don't mind, I'll retell it. If I recall from the Vine Logic expert system or model, the most difficult determinant of a grape yield is fruit set, combination of bud fruitfulness, bunch, flower initiation, and pollination. Okay, I think I can narrow the field on this one. How does the model overcome those critical determinants? We'll deal with them.
Right. So, I mean, obviously, I didn't really go into the modelling too greatly in the project because I just didn't think we'd have a lot of time, and a lot of it's quite sophisticated. But one of the things that we spent a fair bit of time on with the wine grapes was building phenological models. So we modelled the different timings of bud burst and flowering and so forth all the way through, and the kinds of conditions that led up to those. So we were able to, I mean, that was one of the points that I was trying to make, is that there's this kind of there's a non-stationarity in the way that certain weather variables affect different phenological stages within wine production, and they can all then have a cascading effect on yield. So the example is that wind during bud burst is very, very important, but it's not so important in other phenological stages. So I guess one of the things that we did was try to incorporate the phenology as much as possible in those models. The funny thing was, it wasn't so important. So the most important thing was having historical yield. And that was one of the things that really helped us.
Awesome, thank you. Dan, on behalf of us all, thank you and the team for a very insightful presentation, and also for questioning, sharing your learnings, your broader learnings that we've all benefited from. So thanks, Dan, and the team.
No worries. Thank you.